Okay, so these are the power reducing ones. And let's say they have, you have cosine of x equals -5/13, and they tell you that x is in quadrant 2. Okay, and they want you to find sine squared x, cosine squared x, and tangent squared x. So, I'm going to write these formulas out below because we need to write the formulas out so we know what values we need. So sine squared x is 1 minus cosine 2x divided by 2. Cosine squared x is 1 plus cosine 2x divided by 2. And tangent squared x is 1 minus cosine 2x divided by 1 plus cosine 2x. Now, what do you notice that all these three have?
Numbers.
Well, look at on the right side. They all have the same thing. What's the value that they have? Cosine 2x. Yeah. That means we have to find cosine 2x. So cosine 2x is cosine squared x minus sine squared x. Okay? So, do you need to find tangent in this at all?
No.
No. Do you need to find sine?
Yes.
Yes, because we need sine right there. Do you need to find cosine? Yes, because we need cosine here. So we're going to do this first, and then we're going to plug it in here. So, if we're in quadrant 2, the first thing we do, remember, is figure out what's positive and negative. So if we're in quadrant 2, what's positive, sine or cosine? In quadrant 2, what's positive? Sine. So sine is going to be positive, so we leave it positive. Since we don't need tangent, I'm going to leave tangent alone. And I'm going to draw my triangle. Okay. SOHCAHTOA. So, with SOHCAHTOA, we are dealing with cosine because we have cosine here. So, cosine is what over what? Adjacent over hypotenuse. So this side is going to be adjacent, this side is going to be hypotenuse. Hypotenuse we always put here. Adjacent is going to be next to the x. And how do we find the other side? Pythagorean theorem. So a squared plus 25 equals 13 squared, which is 169. So that means a squared is 169 minus 25. Does anyone know what that is?
134.
144? And that means that a is what? 12. So what is sine then? Sine is opposite over hypotenuse. What's opposite x? 12. And hypotenuse is? 13. Good.